Hello friends, welcome to our YouTube channel, Kachpal A Learning. In this video we will continue the previous topic, suppository. So let's start. Topics to be covered in this video are suppository base, method of preparation of suppository, displacement value and its calculation, and evaluation of suppository. First is suppository base. Suppository bases are the inert substances that provide the structure, consistency, and vehicle for the active pharmaceutical ingredient, API, in a suppository. Different types of bases are used depending on the desired release characteristics, route of administration, and compatibility with the API. Here are some common types of suppository bases along with examples. First, fatty bases. Fatty bases are composed of various oils, fats, or combinations thereof. They are often used in rectal and vaginal suppositories due to their slow release and prolonged drug absorption. Examples include A. Cocoa butter, theobroma oil, a widely used fatty base that melts at body temperature and provides excellent drug solubility. Commonly used in rectal suppositories. B. Hydrogenated vegetable oils. These oils, like hydrogenated palm kernel oil or hydrogenated coconut oil, are used in suppository bases to achieve specific melting points and release profiles. C. Suppository glyceryl bahenate, a synthetic fatty base that offers consistent melting characteristics and is often used for controlled drug release. Second, water-soluble bases. Water-soluble bases are used for suppositories that need to dissolve rapidly for absorption. They are commonly used in vaginal suppositories and other types that require quick dissolution. Examples include A. Polyethylene glycols, PAGs, different grades of PEGs, such as PAG 1000, PAG 3350, etc., are used to create water-soluble bases. They dissolve easily in body fluids and can accommodate hydrophilic drugs. B. Glycerinated gelatin. A mixture of glycerin and gelatin forms a water-soluble base that can be used in vaginal suppositories. Third, combination bases. Combination bases are created by mixing fatty and water-soluble components to achieve specific release characteristics and stability. Examples include PAG cocoa butter combinations. A blend of PAG and cocoa butter to combine the advantages of both fatty and water-soluble bases for controlled release. Fourth, miscellaneous bases. There are other specialized bases used for specific applications or routes of administration. Examples include A. Alginates. These are used to create rectal suppositories that release the drug in response to the rectal FA. B. Hydrophilic polymers. In cases where drug release needs to be controlled through hydration and swelling, hydrophilic polymers like piloxamers, pluronic, can be used. Note: it's important to note that the choice of base depends on the characteristics of the active ingredient, the desired release profile, and the intended route of administration. Additionally, the base needs to be compatible with the manufacturing process and should ensure stability and uniformity of the finished suppositories. Now next is method of preparation of suppository. The method of preparation for suppositories can vary based on the type of base used, the active ingredient, and the specific formulation requirements. Here's a general outline of the steps involved in preparing suppositories. First, weighing and measuring. Measure the required amounts of the suppository base in the active pharmaceutical ingredient, API, according to the formulation specifications. Second, melting the base. For fatty bases like cocoa butter, hydrogenated vegetable oils, or glycerinated gelatin, melt the base using gentle heat. This can be done in a water bath or using a controlled temperature melting device. Ensure that the temperature is within the range that doesn't degrade the base or the API. Third, incorporating the API. Once the base is melted, add the active ingredient, API, to the melted base and stir thoroughly to ensure uniform distribution. Mixing should be done gently to avoid incorporating air bubbles. Fourth, optionally, add excipients. If the formulation requires the addition of other excipients like stabilizers, preservatives, or flavoring agents, incorporate them at this stage and mix well. 5th, pouring into molds. Pour the melted mixture into suppository molds. These molds can be made of various materials, including metal, plastic, or silicone. The molds should be clean and properly lubricated to ensure easy removal of the solidified suppositories. 6th, cooling and solidification. Allow the mixture to cool and solidify. The cooling process can be done at room temperature or in a controlled environment to ensure consistent solidification. 7th, demolding. Once the suppositories are solidified, carefully remove them from the molds. Depending on the type of mold and the formulation, this might involve gentle twisting, tapping, or other methods to release the suppositories without damaging them. 8th, packaging and storage. Package the suppositories in appropriate packaging material that protects them from moisture, light, and other factors that could affect their stability. Label the packaging with necessary information, including the medication name, dosage, and usage instructions. 9th, quality control. Before releasing the suppositories for distribution, conduct quality control tests to ensure uniformity, stability, and proper dosing. These tests might include weight variation, melting point determination, and dissolution testing. Now, displacement value and its calculation. The displacement value, also known as the displacement factor or volume displacement, refers to the volume of suppository base that is displaced by the active pharmaceutical ingredient, API, when it's added to the melted base during the preparation of suppositories. It's an important factor to consider when calculating the final volume of the suppository mixture to ensure accurate dosing. Here's how you can calculate the displacement value. Displacement value, dV, equal to total volume of suppository base minus volume of API. In this calculation, total volume of suppository base is the volume of the base before the API is added. It's the volume that would be obtained if you melted the base and poured it into molds without adding the API. Volume of API is the volume occupied by the API. For example, let's say you are preparing rectal suppositories using cocoa butter as the base, and the total volume of cocoa butter in the melted state is 100 mL. You want to add 10 grams of an API. The density of the API is 1.2 grams per milliliter. First, calculate the volume of the API. For this formula to be used is volume equals mass by density. Now putting the value according to question. Therefore, volume equal to 10 gram divided by 1.2 gram per meter L. This gives the volume, which is 8.33 meters L. Second, calculate the displacement value. Formula to be used is displacement value equal total volume of suppository base minus volume of API. Now putting on the value, that is, dV equal 100 meters L minus 8.33 meters L, is equal 91.67 milliliters. So, the displacement value is 91.67 meters L. So, in this example, the displacement value is 91.67 meters L. This means that when you add 10 grams of the API to the melted cocoa butter, the volume of the mixture will increase by approximately 91.67 meters L due to the displacement of the base by the API. The displacement value is important for accurately determining the final volume of the suppository mixture, which in turn helps in calculating the appropriate size of the molds and ensures consistent dosing of the active ingredient in each suppository. Last is evaluation of suppository. The evaluation of suppositories involves assessing various aspects of their physical, chemical, and pharmaceutical properties to ensure their quality, safety, and effectiveness. Here are some key parameters and methods used in the evaluation of suppositories. First, appearance and physical characteristics. Under this, E. Check the color, shape, and overall appearance of the suppositories for uniformity. B. Evaluate for any cracks, surface defects, or signs of deterioration. Second, weight variation. Under this, E. Weigh a representative sample of suppositories to check for uniformity in weight. B. Calculate the average weight and compare it to the target weight specified in the formulation. Third, disintegration and dissolution. Conduct disintegration testing to determine the time it takes for a suppository to disintegrate into small particles. And, for certain suppositories, perform dissolution testing to assess the release of the active ingredient over time. Fourth, melting range or point. Determine the melting point or range of the suppository using appropriate techniques, e.g., capillary tube method, differential scanning calorimetry. And also, ensure that the melting characteristics align with the intended use of the suppository. Fifth, uniformity of drug content. Under this, analyze multiple samples for the content of the active pharmaceutical ingredient to ensure uniformity. And, compare the measured content to the expected content based on the formulation. Sixth, for measurement. Determine the FUR of the suppository, particularly for formulations that may impact the local FUR environment, e.g., vaginal suppositories. Seventh, hardness and brittleness. Under this, evaluate the hardness of the suppositories to assess their ability to withstand handling and insertion. And, check for brittleness, as overly brittle suppositories can break during use. 8th, stability testing. Conduct stability studies to assess the suppository's physical and chemical stability over time under various conditions, temperature, humidity, light, etc. And also, monitor changes in appearance, drug content, and other relevant parameters. 9th, microbial testing. Perform microbial testing to ensure the suppositories are free from harmful microorganisms. This is especially important for suppositories intended for vaginal or rectal use. 10th, packaging and labeling. Inspect the packaging for integrity and proper labeling, including accurate dosage information and storage instructions. 11th, in vitro release studies, if applicable. For specific formulations, conduct in vitro release studies to assess how the active ingredient is released from the suppository over time. 12th, assay of excipients. Depending on the formulation, assay excipients such as preservatives, stabilizers, and flavoring agents to ensure their content is within acceptable limits. These evaluations help ensure that suppositories are of consistent quality and meet regulatory standards. Pharmaceutical manufacturers and regulatory agencies establish guidelines for each evaluation parameter to ensure the safety, efficacy, and reproducibility of suppositories. It's important to conduct these evaluations in a controlled and validated manner to maintain the quality of the final product. Thanks for watching this video. If this was helpful, then please kindly subscribe the channel. Thank you.